Hello students, how are you? Today I am going to start a new topic of chemistry of class 10th, which is a functional group of carbons. Let's start without wasting any time. Carbon. As we know well, there are basically five functional group of carbon in class 10th book of CBSE, which is first of all alcohol. The second is aldehyde. The third is ketone. The fourth is carboxylic acid. And the fifth is halogen group. One more additional group we can say, which is mostly added to the halogen group, but we can also consider it alone, which are alkene, and alkyne. So basically, students, today we are going to discuss about these eight functional groups, which are alcohol, aldehyde, ketone, carboxylic acid, halogen group, alkane, alkene, and alkyne. Right? Their formulas, general formulas, their nomenclature, and their example, so that you can easily identify and easily can understand what's their IUPAC name. Okay, so let's begin first of all with the alcohol. Okay, now let's begin with the alcohol group, which is the first group, alcohol. You have heard the name alcohol several times, right? But what is actually alcohol? We'll understand its properties later. First of all, we'll understand its structure. So basically, as you can see here, which is alcohol, the last is OL, right? OL. So how will it work? For example, any carbon group, suppose CH3 and OH. CH3 OH. How many carbons are there? There are only one carbon. So we'll keep its name methe, right? And it is OH is here. So it is all methanol, right? If we say C2H5OH, right? So how many carbons are there? There are two carbons, five hydrogen. It will be ethanol. So basically the suffix is all. When you see the OH group in the attachment with the carbon, right? So it will be alcohol group. Simple, right? Methanol, ethanol, propanol, butanol, hexanol, heptanol, so on, right? So basically the general formula of the alcohol is ROH, right? ROH. R is any carbon chain by which OH group is attached, and this OH group is alcohol, right? And when we keep its name, so its name will be added after adding the OL, right? Methanol, ethanol, propanol, butanol, pentanol, like this, right? So this was the alcohol. Now come to the next, which is aldehyde. Okay, students, now the second group is aldehyde. Okay, so students, as you can see here, aldehyde, so its suffix is al, al, right? How will you use it? I will tell you. Basically its formula is R, which is any carbon chain by which CHO group will be attached, right? CHO group will be attached. Whenever you see CHO group is attached to any carbon chain, just name it as aldehyde, right? Sometimes it is written like this, or sometimes it may written like this: R, C, O, and H, right? Do not confuse this with the alcohol, right? In the alcohol, this is the aldehyde. It is the aldehyde. I'm also telling the structure of alcohol so that you cannot get confused. R C O H, right? R C O H, or R C O H, something like this. Both structures are same. So it is alcohol. It is alcohol, and it is aldehyde, right? These both are aldehyde. Carbon will be attached with hydrogen and oxygen, right? Means this oxygen will be directly attached to the carbon with double bonds, right? Means two electrons will be shared with the carbon. right? So it is the aldehyde. For example, let's say example, for example, CH3CHO. It's a simple structure, you can easily identify it is a CH group is attached to the carbon, right? So what you will name it, you will name it what, how many carbons are there, there are two carbons, 1 and 2, so it will be eth, right? So ethane, and it is aldehyde group is attached. So the always remember for the aldehyde group the suffix will be al, the suffix will be al, so it will be ethanol, right? For alcohol it was all, right? It is al, right? Ethanol and ethanol. Ethanol is aldehyde and ethanol is alcohol. Clear the difference between alcohol and aldehyde, the structural difference, the IBC naming difference. Clear? Okay, now let's move forward to the next group, which is the ketone group, right? Just a second, I'm raising it. Okay, student, now we'll discuss about the ketone group, which is the third group. As you can see here, ketone, the suffix will be ONE, right? How will you remember? Here you can see ONE in the ketone, right? So by this on, just remember it is ketone and the suffix is on, right? The general formula is RCOR, right? Or sometimes it is written like this, RCO and R dash. R dash means both carbons cannot be same. Sometimes can sometimes will be same. Sometimes will not be same number of carbons. So that's why it will be written R dash, right? But carbon is attached with oxygen by double bonds, right? So whenever you see ketone group, so how will you identify? You will identify just by this main C double bond O, and both side are carbon attached to the main carbon group, right? It is ketone. For example, let's take example. For example, C2H5 and C double bond O, then C3H5 7, right? So you can see here how many carbons are there. There are 2 carbon, 3 carbon, and plus 3, 6 carbon are there. How many carbons are there? There are 6 carbons. Now just count: meth, eth, prop, but, paint, hex, right? Hex. Now you can see here that this group is attached. Which group is this? This group is the ketone group, right? Because carbon is attached to the oxygen and both side the carbons are attached to the central carbon. Sometimes it is central, sometimes it cannot be central, but remember oxygen will be attached with carbon, right? It is the key point. C double bond O, right? So what it will give its name? It will be on. So hexanone. Its name is hexanone. Clear? One more example we can say CH3, CH2, CH2, then OCH3, right? These all carbons are attached together. Remember, I'm not taking the open structure, open chain structure. I will let me tell that also. So how will you name it? Count first of all number of carbons: 1, 2, 3, 4, 5. Right? So how will you understand this? Just see this carbon, right? It has oxygen, right? It is attached with the carbon. That's why it is ketone group. Now how will you name it? 1, 2, 3, 4, 5. Meth, eth, prop, but, paint, penta. Now it is ketone group, so ON will be attached pentanone. Clear? So here I've told you about the alcohol, aldehyde, and ketone. In alcohol, there was all, right, and the identifying group was OH. For aldehyde, it was al the suffix, and the identifying group was CHO. Now it is ketone. The suffix is on, and identifying group is C and O, right? Carbon and oxygen. Clear? Now let's move to the fourth group, which is the carboxylic acid group, right? Let me raise this, then I'll tell you. Okay, one thing more. See, if you are getting any confusion with the open chain structure, let me tell that also. Raise it. If you know how to make open chain structure, that is good. If you don't know, I am just telling you. Okay, as you can see here, these are the carbons attached to the hydrogen, right? So simply what it means, it is carbon, and we know well that valency of carbon is always 4, right? Means only four, either hydrogen or any supplement, any element can be attached to the carbon. So this carbon is attached to the three hydrogen, right? So one carbon attached to the three hydrogen. Now this carbon attached to the two hydrogen, and this carbon will attach together. Now this carbon, two hydrogen. Now this carbon, this oxygen, and remember when there will be oxygen, oxygen have two valency, then it will share two electrons, then double bond, right? And then one more carbon, and then three hydrogen. So as you can see here, this is the ketone group, and this is the open chain structure, right? And it is the closed chain structure. Both are same, but the writing formation is, it is short, it is some lengthy, right? So don't get confused with these structures. Just identify the name, identify the group, and name it. Clear? Now let's move to the fourth group, which is the carboxylic acid group. Okay, let's begin for the fourth group, which is the carboxylic acid group. The suffix will be, who will say, just comment me. The suffix is the OIC, oic, right? And the general formula is R C double bond O and OH, right? Or sometimes it may written like this, R C OOH. So these two are the same formulas, general formulas of carboxylic acid. So do not confuse, okay? COOH, COOH, both oxygen are here, right? But the way of writing are different, little different, is no problem for this, right? And the suffix is OIC, oic. Let's take some example. For example, CH3COOH. So tell me what's its name. Can you tell me? Just count the carbon first of all. There are two carbons, which is the meth, then second is eth, right? It will be ethane. Now you can just simply identify the functional group, which is the carboxylic acid. So the suffix will be OIC, oic. So ethanoic, and ethanoic acid, which is also known as the what? Acetic acid, right? It is also known as the acetic acid, but the IUPAC name is ethanoic acid because two carbons are there, and it is the carboxylic acid functional group. Let's take one more example. C2H5 C double bond O, then OH. Who will say the name? Look here, children. As you can see here, never confuse with this OH. Do not think that if it is OH, so it is alcohol. Remember, this is also oxygen, na? There is also oxygen attached to the carbon, to the same carbon. If the same carbon is available there, so what will say the name? What will see the name? It is carboxylic acid group. No, do not confuse with the alcohol or aldehyde or ketone, something else. Just identify the carboxylic acid group name, functional group name, and just keep its name. So there are two carbon and one three carbon. So it is meth, eth, and propane, and simply it is carboxylic acid group. Just write the name carboxylic acid. So propanoic acid. Let me check another chalk. Propanoic acid. Clear? So it was carboxylic acid, which you have understood well, I think. So we have completed the four functional groups. Now let's go to the fifth functional group, which is the halogen group, right? Okay, so the fifth group is the halogen group. Do you know what are the halogens? Do you know? Let me tell you. The halogens are the fluorine, bromine, and iodine, right? Why they are called halogens, I will tell you later, but first of all, understand the halogen group. So fluorine, chlorine, bromine, iodine are the halogen groups. So when simply carbon is attached, any carbon chain is attached with any of the halogen elements, so it will become the halogen group. For example, if it is carbon chain which is attached to the chlorine, right? So it is the halogen group then. And for suffix, the suffix will be simply what element will you choose. So the name of the element, for example, chloro, right? Chloro, fluoro, bromo, iodo, it will be attached in the starting of the name. For example, if we are saying CH3Cl, right? It is chlorine attached to the carbon, it is halogen group, so it will be chloromethane, right? If it is written like this, C2H5Cl, so what will this? It will be chloroethane. Or if suppose fluorine is attached, right, F, then fluoroethane, and so on, right? It is very simple. There is nothing to worry about this group. Just identify the element and just put the name, right? This was the halogen group. Now the last but not the least is the alkane, alkane, alkyne. I will tell thrice of them together so that you can easily understand it. You do not get confusion, right? Many of the students get confused that what is methane or methene, or why methene is not formed, how methene is formed, or how methene is not formed, or how methine is not formed, what is the common structure, what is the functional structure, what is the type of examples are there. Are a lot of questions in the student's mind, so I'll clear them in the one screen, one board, right? Let's move forward. For alkane, the suffix is in, and the general formula is CnH2n plus 2, right? It is the general formula of alkane, CnH2n plus 2, right? And the suffix is ane. For example, if you are writing carbon 1, right, the value of n is 1, so hydrogen it will be 2, the value of n is 1, so 2 1 2 plus 2 4, right? 2 1 2 plus 2 4, so C1H4. For this, what will be its name? When one carbon is there, then it will be methane. Meth means one carbon, and the suffix is ane, methane, right? If you want to understand its open structure, so what will be there? It will be carbon is attached to the 4 hydrogen, right? So it is a methane, right? It is a methane. But remember only one thing, that in alkane there are only single bonds between the carbon chain, always, right? There are always single bonds between the carbon chain. How much the length of the carbon chain will be there, it doesn't matter, but the bonds between them will be only single bond. For example, if you want to write C3H, what will be here? If carbon is 3, so hydrogen will be, tell me, 2 3 are 6, 6 plus 2 8, so 8 hydrogen will be there, C3 at 8 the hydrogens, right? So the name will be, how many carbons are there? Meth eth prop, prop, and the suffix is ane, propane. Clear? It is a propane. Now let's understand its structure, open structure. 3 carbons are there, so 1 carbon, 2 carbon, and 3 carbon. How many hydrogen are there? 8 hydrogen, so 1 hydrogen, 2 3 4 5 6 7 and 8, right? It is a propane, and both are same, both structures are same. It is open structure, it is closed structure. Remember only one thing, in an alkane, that carbon will have only single bond. Clear? And the suffix will be in. Clear? Now let's move forward to the alkene group. So understand now alkene, and do not get confused alkene with alkane. Alkane and alkene structure, formula, and spelling are different. Here it is E and E, right? Alkene, and the general formula is CnH2n. In alkane, the formula was CnH2n plus 2, but for alkene, the general formula is CnH2n only, right? And the suffix is ene. Suffix is ene. One more thing you have to understand and remember, which is most important, is the alkene will have at least double bond between any of their carbon, at least one double bond between any of their carbon. For example, if it is C2H. Now how many hydrogen will be there? You can see here, if two carbons are there, the hydrogen will be just its double, 2 to the 4. Then hydrogen will be 4. Right? What's its name? Its name will be, two carbons are there, then meth and eth. Eth. Now suffix will be ene. Then ethene. For alcohol, that was ethane. Right? It is the ethene. And if you can want to see the open structure, so see the structure, there are two carbons, and remember for alkene double bond will be there, double bond is there, and remember the remaining are carbons. Okay, as you can see here, that both structures are same, but the difference is there type of writing, and the second is carbon has two double bond between them, right? So it is ethene. One more example you can say, for example, C3, then H. I've told you the number of hydrogen will be as the double of number of carbon, so it will be 6. C3H 6. Its name will be meth probe, and the suffix is "ene", then propene, and its open structure I can show you. There are three carbons, so one carbon, two carbon, three carbon. I've told you at least one double bond should be there between the number of carbons, so let draw a double bond between here, between these two carbons, and here will be single carbon bond, and the remaining bond will be attached. And so remember one more thing, that carbon has maximum 4 bonds because its valency is 4, right? So this carbon has 4 bonds, this carbon has 3 bonds, so one more bond will be here. This carbon has 2 bonds, then 3 and 4. Draw here, do not, that doesn't matter. Now just draw the hydrogens, and this is the structure of propene, and it is the structure of ethene. Clear? So just remember, alkene has double bond between any of two carbons between them, right? And its suffix is "ene", and its general formula is CnH2n. For alkane, it was CnH2n plus ka 2, right? It was for alkane, and for alkene, it is CnH2n, right? Achha, one more question. The student get confused that the structure of methane, right? I'm just trying here. Methane is not possible. Methane is not possible. Methane structure is not possible. Methane is not possible. Methane compound is not possible. Why not possible? Do you know? Because we know well that meth has only one carbon. Meth has only one carbon, and here it is ene. Ene means it is alkene group. Alkene group should have double bond between two carbon. I have told you, alkene should have double bond between two carbon. As you can see here, here is only one carbon, right? And if you draw the structure of methane, so what will be happen? Only single carbon is there. So what will happen? One hydrogen is there, one hydrogen is there, right? General formula is C1 and hydrogen 2, but the two bonds will remain vacant because there is not another carbon here. That's why the structure and the compound of methane is not possible. Clear? Remember this point, okay? Methane is not possible because there is only single carbon, and due to this double bond will be vacant, and there is no extra number of carbons or hydrogens. That's why it is not possible. Now let's move to the last group of this topic, which is the alkyne group. Okay, now the last functional group is alkyne group. So for alkyne, the suffix is YNE, right? YNE, and the general formula will be CnH2n minus 2, right? Do not confuse with alkane or alkene. For alkane, I have told you CnH2n plus 2, right? For alkene, it was CnH2n, right? I'm mentioning also here alkane and alkene, right? For alkyne, it is CnH2n minus 2. For alkene, it is CnH2n plus 2. For alkene, it is CnH2n. Right? So these were alkyne. Now just understand the examples and the topic will be finished. For example, C2H. Now count yourself. C2H. According to the formula, if the carbons are 2, right, then hydrogen will be 2 to the 4. 4 minus 2, 2. C2H2. Now let's understand its name. It is a meth. And as you can see, it is alkyne group, so YNE will be attached. ETHYNE, ethine. Right? Let's see its structural formula. Its structural formula, it will be carbon and carbon. I've told you alkene contains single bond, alkene contains double bond, and alkyne will contain triple bond between any of two carbon groups. Right? For example, I've told you carbon and carbon, and it will contain three bonds. And two hydrogen are there. So one hydrogen is here, the second hydrogen is here. Carbon has four hydrogens, 1 2 3 4. This carbon has four hydrogen, 1 2 3 4. Right? Both valencies are completed and the structure is also completed. It is the ethine. Clear? Let's take one more example. C4H. If carbon, there are four carbons, so how many hydrogen will be there? There will be 4 2 8, and 8 minus 2, 6 hydrogen. What will be its name? Its name will be, there are four carbons now, so meth, eth, prop, but. The suffix is YNE, butane, and its structure will be four carbons are there, so one carbon, second carbon, third carbon, and four carbon. And I told you three bonds, triple bonds will be there between any of the carbons, any of two carbons. So let's draw the triple bond between here. You can also draw here or here, it doesn't matter, right? And then carbon will be there. Or if you get confusion, remove from here, put here, right? Now just attach the fourth bond. This carbon has four bonds, 1 2 3 4 bonds has completed. This carbon has four bonds, 1 2 3 4 bonds completed. This carbon has 1 2 bonds. Now third bond and fourth bond is completed. This carbon has one bond. Now second, third, and fourth bond completed. Now just simply attach the hydrogens. This hydrogen, second hydrogen, third hydrogen, fourth hydrogen, fifth, and sixth hydrogens are completed. So how many carbons are there? 1 2 3 4 carbons are there. How many hydrogens are there? 1 2 3 4 5 6 hydrogens are there. So this is the opening structure of butane, and this is the closed structure of butane. Both are same, but the way of writing are different, right? So remember 3 points. The first point is alkyne always contains triple bond between any of two carbons. The second point is the general formula of alkyne is CnH2n minus 2, and the third is the suffix of alkyne is YNE. Right? Okay, now let's summarize all the functional groups together so that you can clarify everything. Okay, now let's summarize all the functional groups, their suffixes, and also their general formulas. As we have discussed about the alcohol, the second was aldehyde, then say with me, ketone, then carboxylic acid, then halogen group, and then alkane, then alkene, and at last alkyne. So we have discussed these all the functional groups. Now understand their general formulas. For alcohol, I have told you it was ROH, right? OH will be attached to the any carbon chain. It is ROH, it is alcohol, and the suffix is OL, all, right? For example, butanol, propanol, alcohol, anything, right? Now the second is aldehyde. So the general formula is RCHO or RC, right? Both are the structure of aldehyde, and the general formula suffix is al. Now for ketone, it is R C O R, or we can also write R C double bond O and R, and the suffix is O N E, on. As I told you, methanone, propanone, butanone, heptanone, hexanone, so on. But methanone is not possible. I will tell you later about it. Carboxylic acid, the structure is R C O O H, or we can also write R C double bond O and O H, and the suffix is oic, right? Ethanoic, pentanoic, hexanoic, right? Like this. For halogen groups, it is R is attached to X, and the X are chloro, fluoro, bromo, and iodo. The suffix will be according to its name. It is not necessary to write the names chloro, fluoro, bromo, iodo, right? The next will be alkane. So CnS2n plus 2. The suffix is ane, methane, ethane, propane, butane, hexane, pentane, nonane, decane, so on. For alkene, it is CnH2n. The suffix is ene, ene. It is ane, it is ene. And for alkyne, it is CnH2n minus 2. And the suffix is yne, alkyne. So students, have you understood well about this all the functional groups, their general formulas and also their suffixes? So by watching this video, I do not think that you will get confused after watching this video. And if you also get any confusion after watching the video, just comment me in the comment box or join me on the Telegram, and we can discuss your problems, right? Now time is less, work is more. It is now October, it is going to be started, it's 1st of October, and now exams are near, boards are near, so do not get any confusion. Just keep in mind, start learning, make your timetable, be punctual, and just crack the exam and grab the world, right? Time is less, work is more. You get life only one time. Everyone get life one time. We have one life, one chance to occupy what we want, to complete our dreams. Once time's lost cannot be regained. So don't waste your precious time in playing a PUBG or something else games, right? Just focus on your study, focus on your work, focus on your success, focus on your career. After getting your career, after getting your success, those who are just making your fun, they will think, oh my god, he was serious about his success, he was serious about his career, and they will only watch, and he will go and go on, right? So all the best for your career. Thanks.